This conference will now be recorded.
Hi, Judy. How are you? I can't hear you. Are you talking? I can't hear you. I can see you talking, but I can't hear you talking.
I think I unmuted
Yep.
myself. Yeah,
I
okay.
can hear you now. Yes. Good.
Please close confidential windows. Okay, I'm just reading this screen warning. Okay, I'm about to share my windows, I think. Yes, okay, good. Now you all see.
Okay, we
My
have
screen.
a number of people on. So why don't we get started? Welcome everybody to the Clean Network weekly teleconference. Before we get started with our presentation for today, I'd like to ask if there are any announcements.
This is Katie. If no one else has one at the moment, I'm going to throw one in there. We're in the middle of our clean webinar series going on. I've sent out some messages to the Literacy Network, and I'll put the page in the chat here as well. But just reminding people to share that with their teacher networks and help us get more people attending those. We have the 4 regular ones, and then on March 25th, we'll have a new one that's focused on Climate Literacy Principle 6, which a lot of teachers are interested in. That's how the principle focused on the human impact on climate. So
great. Okay, any other announcements? Go ahead.
This is Jen. I had a question and an announcement. My first question was, do we have a call scheduled to talk about AGU?
We do, Jen. It's in, I think, 2 weeks we have that scheduled.
Yeah, it's on the schedule for the 19th.
Yeah.
Okay. Great. And then my announcement is that we are, so this is Jen from the Wild Center in upstate New York, and I just wanted to make an announcement that we have our second of 3 New York City Youth Climate Summits happening this Friday at Columbia University. It's being organized by one of our alumni and who's an engineering student at Columbia, and we have, I think, around 140 or 150 students, high school students registered to attend. So, and then our next summit will be in May in Brooklyn. So just shouting out that we've got a lot of youth climate summits happening.
Congratulations.
Yay.
Thanks.
Then let's see, Jim Callahan from climatechangeeducation.org. Just looking that we are now about a month away from when a lot of Earth Day events start. Here in California, there's one or two every weekend. Just encouraging people to look those up. They're a great way to connect both education and action, especially at the city and state and county and community level. The events in our area tend to be from 800 to maybe 4,000 attending. There are larger ones like in San Francisco. We don't tend to do that one. That tends to be a little bit more just toward political advocacy in politics. Of course, we're a little more science education and science action. But Earth Day is just it's a very busy, great time to connect more broadly with the community. And if anyone's likewise doing it, it's great to compare notes and techniques and what works well.
Great, thank you, Jim. Any other announcements?
Yep, this is Frank Neapold over at NOAA. I just wanted to highlight the, like Katie, the webinars. What I try and do on climate.gov in the teaching climate section focused on professional development is weave together a lot of disparate related professional development opportunities. So if you look there, you're going to see the ones that Katie, you've posted and continue to promote them, but also other related webinars that are relevant to teaching climate and energy. So, and the other thing that I want to just, so that's there, look at that, use it if it's helpful, but also if you have something that you think should be there, don't hesitate to let me know. And I can always post them. Yeah, already, Kristen, funny, that's already there.
Where are you posting these, Frank?
So in the climate.gov teaching climate section, there's a module called professional development, and in there is where I promote them. So like, Kristen just put the institute that Climate Generation is doing in Washington, D.C. So that is already in the system. The whole idea is to try and fill as many of these opportunities as possible so that the community is working better. So you can see right there, Kristen, there is your institute being promoted through climate.gov, for example.
Frank, I have a suggestion to make. I don't know if you find this useful or if others would, but I do get these regular emails from One NOAA, which is a list of webinars that they have. Some of them
Yep.
are very technically oriented, but I've actually assigned as extra credit for some of my students in my global climate change class to attend some of these webinars. And so you'd really have to curate it. You'd have to pick ones from there, but the power of some of them is to show the connections between climate change to issues in communities or to finance. Like there was one which was given by an economist that showed the value of managing the uncertainty of a hurricane on businesses and how that impacted the businesses. So in the context of my students, that was relevant. But you might find some that you might post on the teaching climate section. Like I said, there won't be a lot of them, but there could be some that are quite relevant, and you just have to peruse the list to identify which ones they are.
Great minds think very alike. Tamara posted one today. Couldn't be there because I was in the Clean Leadership Board, but the rising carbon dioxide's effect on land and oceans from is one of those. So you got it. But more, sometimes if other professional societies do these or other partners do them. So, I think just a general principle, if you find something that you think is wonderful that should be getting more attention, more support, more attendance, please don't hesitate to put it my way, and I'll post them as quickly as possible if they make sense.
Okay, great.
Thank you.
Any other announcements?
Yeah, this is Kristen. Thank you for posting that, Frank. Just to reiterate, we have a couple cool things going on. Our Summer Institute coming up in August in Washington, D.C., focusing on the humanities. Our Talk Climate Institute coming up in 2 weeks, focusing on anyone that wants to think about crafting their climate story and how to use it and apply it. And we are starting our Zero Waste Challenge, just a fun initiative starting next Monday, and there's information on that. And finally, I just wanted to toot Minnesota's horn because yesterday our governor announced a goal of generating 100% of its electricity from carbon-free sources by 2050, making us the 3rd state in the nation to be making these goals. So thank you. It's a good starting point. We need to do more, but we're pretty excited.
And Jim, and Kristen, Jim here. I hope, I don't know if you heard the reports on things, but from your institute already having a great impact in DC and Maryland, what was happening at the AAAS conference was astounding. Natalie is amazing. She's pulling together a wonderful team. And so thank you on your work on because you helped to lay the groundwork where there's the support system for that to be possible. It was quite astounding. 2 stage shows, the kids did all kinds. It was really good.
Oh, awesome. That's so great to hear. So just a reference to Jim, the Institute's being held at an independent school we worked with for 2 years to help them make their 6th grade humanities curriculum climate centric. And so we'll be kind of showcasing their work and the curriculum that stemmed out of it.
Great.
And Frank is setting up a really cool field trip the 3rd day, right, Frank?
I have the lead into the climate change office at the city. So that is
awesome.
We will figure that out. Absolutely.
Yeah.
Don't worry, it's going to happen. Don't worry. But to that end, I also wanted to put a post into the chat about the Green Catalyst from the Green School Network. The December edition was all about climate literacy and educating with the future mind. A lot of us contributed to that, but specifically Natalie's article is in there, Jim, the one you mentioned. So I would encourage you everyone to look at that if you haven't already checked that one out.
Great. And Frank, it'd be very exciting. Know that when those kids do a field trip from Lowell, it's not only are they coming to observe. I mean, I'd be tickled by this. This is very fun. But they can bring cameras on how they're learning how to essentially assess the energy efficiency of the interior and exterior of buildings in order to share how that's done with the rest of DC and Maryland. So they may come and be active analyzing whatever building is going on in a fun way, you know, and this is a place that you're efficient. This is a place we could do things there. And people like they went around their own school. So they're the groundskeepers or the people who do the maintenance were just loving it because the kids were now caring about the heating of the building, the cooling of the building, and learning so much from each other. I don't think you could ask for a better set of field trip kids because they're just so eager and active and knowledgeable. So,
Thank you, Jim.
Okay, I think we should
ready to
move
take
on.
action.
I think we should move on to our presentation today.
Would you mind if I give one more announcement?
Okay, go ahead. Who's this?
This is Reb Anderson with ACE.
Go ahead, Reb.
Hang on one sec. Someone's chatting me. I need to hang. Okay, sorry. We have our 4th annual Earth Week Climate Teach-In that's happening coming up next month, right around Earth Day. It's going to be on April 18th. I'm going to put the link into the chat. Oh, sorry, Kristen, I think I just chatted it to you. There we go. And so, yeah, it'll be 1 hour. It'll be hosted on Zoom. We'll have special guests. So we're inviting teachers from around the country to join with their classes, be playing trivia for prizes, taking Q&A with our guests. It's a great time, and we'd love to get any teachers of all grade levels to join us. So if you have a teacher network, it would be great to get that out to them via social, newsletter, website, whatever you got. And I would be happy to, I will send out some more information on the listserv as well.
All right, great, thanks. Any other last announcements? Okay, great. So we will move on to our presentation for today. We have Judy Twedt. I hope I pronounced that right.
Yes, you did.
Judy, good. Judy creates music from climate data and studies how people relate to both visual and auditory displays of climate information. She has a master's degree in atmospheric science and is a doctoral candidate at the University of Washington and a 2018 invited speaker for TEDx Seattle. Her work is marked by the goal of connecting to climate change across differences, whether disciplinary, socio-cultural, or generational. She's also a 5th-generation Washingtonian from a family of farmers, settlers, and loggers. And she is going to talk to us today about climate data communication through digital sound arts. So with that, Judy, I will turn it over to you, and I think your slides are already up.
Great, thank you. Can everybody hear me okay?
Yes.
Okay, this is my first time using this software, though it's a lot like Zoom, so I feel pretty comfortable right now. Thanks for that introduction, and it's also great to connect with this network. It's, wow, really neat to hear so much that's going on. And I have a presentation here that is maybe 45 minutes, although I think I might try and shorten that so that we can just have a bit more discussion. Can you tell me also kind of the expectations for the length? It's an hour long meeting, correct?
Yes.
Okay, great. Yeah, so I'll shorten this a little as I go. And let me move this thing here and maybe just go like this so I can see the slides. All right, like that. Okay, so I chose the title of this talk as Transgressing Timescales, and the word transgressing is really intentional. Because there are so many kind of structural ways in which we're taught to think on very short timescales, and so it takes a lot of work to think on longer timescales, and that's such the crux, I think, in many ways of climate communication. So this presentation is a bit of a mixture of both sharing some of the ways that I communicate what I'm doing to broad audiences so that you can see that and maybe ask questions or give feedback, and then also kind of some reflective work on a recent workshop I just gave for young people. So a couple years ago, I like reading this comic XKCD. This And this one in particular is about this problem with timescales. So this is a couple friends commenting that the weather is so cold, so much for global warming, right? And he posted this comic, I think, in 2014. And the friend says, oh, this used to happen all the time. You're from St. Louis, right? On average, it used to get below 0 degrees Fahrenheit. There are a handful of days per year, but you haven't had a day like that since the 90s. And then in 2014, when the first polar vortex hit, it dipped below 0 for 2 days, and everybody freaked out because what used to be normal now feels too cold. And the friend says, it is cold. And then in the future, right? Look at this ice in St. Louis. So much for global warming. So this is a comic about shifting baselines has now been studied analytically, and there was a paper that came out in PNAS. Some of you may have seen it already just last week. Several scientists looked at Twitter data, and they found that shifting baselines, that people no longer sort of think of weather as remarkable if they've experienced warmer or colder periods over the sort of a 3 to 5 year shifting baseline. I thought that was really interesting when I saw that, and it just immediately reminded me of that comic and how apropos that is to what our winter this year, and to a lot of the questions that I think about with music and climate change. So when we're often sort of thinking about timescales, we think of, this is one figure from another PNAS paper that came out in December. I should say I'm not sure exactly who the audience is here, so that's the Proceedings of the National Academy of Sciences. And I think this figure is fascinating and also problematic. Problematic because it does show the scale of possible change, in the next 100, 150 years. But when we give equal area to this change over time here, even though we show analytically, sort of through the, you can point out to audiences and to viewers that these timescales are different, I worry about what our brains actually think about this, especially people who are sort of not used to looking at this data regularly, when we sort of think, well, this change has equal area and this change has equal area, and this has happened before. And I also think there's sort of just genuinely an interesting question of how do we relate to the fact that we are experiencing both rapid human-driven climate change, and how do we make sense of that in the context of geological climate change. So this gets to the heart of this question I want to explore with you all today, which is how do we help audiences develop this cognitive flexibility to hold a lot of different time scales in their minds, because we have to be able to do that rapidly when we're making decisions about climate change, both for our own lives and then for policies and other decision making. We have some tools to help us with this from visual media, and those have been inspired largely by the satellite era and by the microscope. And even popularized in children's media. So here's an analog for kind of what I'm thinking about. This children's book, Zoom, by Istvan Banyai, which came out about 10 years ago. He's written a couple of them now, and it is about zooming out spatially and holding all of these different scales in your mind at once. So I'll show you just a few slides from this book. This is a picture book, no words. This is from the middle of the book. We've already zoomed out quite a lot. If you turn the page, this is the next image. Turn the page again. And again, and again. And it ends with what might be, looking at the Earth from space and seeing it from a satellite's perspective. So I've been thinking about using that as an analog for zooming out in time. And now I'm going to sort of apply that same process to the Keeling curve carbon dioxide data set. And fortunately, the Scripps Institution has made figures that make it very easy to do this. And I should say, when I show this to general audiences, when you're giving a talk and you can tell everybody's paying attention, they're not reading their phones, and then you get to the next slide and half the people, they're looking at their phones. Generally, I find that audiences really kind of cue in at this section right now, where I say, okay, we're going to go across several different time scales. We're going to start with this data set from this, I show them where this comes from, this Mauna Loa Observatory in Hawaii, and it's a measurement of carbon dioxide in the atmosphere. And say, let's look at it at 1 week. And there's nothing remarkable about this. You see CO2 is just bobbing around 410 parts per million. And then I say, well, just like in that picture book, we'll zoom out to a month. And it's not really that different. But we can zoom out to 6 months, and now it looks like maybe there's this little dip, but we don't really know what that means. If we zoom out further, then we see this this peak and trough. 2 years, and it looks like there's a trend, that there's a peak and trough every year. And I talk with them about, or ask them why that that might be, and think about the seasonal cycle and the role of vegetation in drawing down carbon in the spring and summer in particular. And then look at the whole record and say, okay, now the signal that you see is not the seasonal cycle, although you can still see that. The main signal is the rise due to human emissions. Now, if we want to zoom out even further, then we have to go not from an in situ record, because this started in the late 50s, but we have to look at the ice cores. And I will briefly explain to them how ice cores trap bubbles of air and how that creates a record. And then we go back further and we keep zooming out in time. And now you see a different story, right? That it's been flat for the last couple hundred years until the 1900 approximately. And then we zoom out more and we look at the entire record. And then I showed, talk about ice ages and how this vertical line is that 60-year record, and really reflect on how different time scales show different stories. And then at this point I say, okay, so now we're looking at, we've looked at several different time scales of this data set. Let's go back to the one from the last 60 years that shows the in situ record, and say, what we're doing is we're showing something that shows change over 2 careers worth of work, and looking at it all in one instant. But what happens to our perception of that data if, rather than looking at it all at once, we experience it over time? And one way we can do that is by having the data mapped to sound rather than mapped to a single static image. And I've done that, so I've made it's called a sonification, and I take each month of data, each of those little dots, and instead of plotting it visually, I map it to a note. And the notes are higher if the CO2 concentration is higher, and they're lower if the CO2 concentration is lower. So you'll hear each of those points over time. And I will show that, I'll play that for you. Oops. In a different program here. And please tell me right away if the sound does not work. I hope that it will, because I haven't tested Audition before in this software. So I want to check in. Was everybody able to hear that okay?
Yes.
Yes.
Okay, good. That makes me feel better. So that was this slide. So now let's think about, that was just this 60-year record, and you heard that 60 years compressed into about 92 seconds. You couldn't get it all at once. You had to wait to hear a little bit of it. So in that sonification, that soundtrack that you just heard, 1.6 seconds was playing 1 year of data. Now, if I was going to show, for example, the 318-year record, keeping the same tempo, we'd have to wait 8 minutes to hear all of that. If I wanted to play the longer records, again, keeping that same tempo, 10,000 years would take 4.5 hours, and the whole 800,000-year record from the ice cores would take over 2 weeks. Nobody would listen to that. But this is all to say that, you know, I think it's important to really slow down and reflect on how much longer this time scale is than this one. And it's really easy to trivialize that when we just flip from one to the next. And if we don't have any experience of actually sitting and waiting and, you know, listening over some duration to that. So I'll show you one more data set that I've sonified. So that was an iconic record of climate data, the Keeling curve. Another iconic record is the satellite record of sea ice over the Arctic Ocean. And I explained to the audience what sea ice is. This is what it can look like, what it very commonly used to look like. And this is the data set represented visually. So now we're looking at 32 years of data. Again, especially for undergraduate audiences, I remind them that this is longer than most of their lifetimes. And similar to the last piece, I took each month of data, and I explained that this plot here is showing the area of ice, but it's subtracted the average, so it's showing just the anomaly. And so you can see that the area was clearly has gone down over time, even though it's going up and down if you look just within a shorter time frame. And for this piece, I wrote it for piano, and I'll show you what the score looks like. So the right hand is playing in the upper staff here. The right hand is playing this seasonal cycle. The left hand the right hand is playing the sea ice data. So each note represents 1 month of data. The left hand is repeating over and over again a seasonal cycle. And it uses the piano keyboard like the y-axis. So what would be the 0 line here on the graph is kind of is approximately the region on the piano where the left hand plays this seasonal cycle. And so over time, the right hand goes lower and lower, and you can both hear and see visually this decline in ice. So I'll play that for you now. And this is a video because this piece also has gesture in it. And this was played by Christina Lee. Make this a little larger. Okay. Come back. Oops. Let's see. Here we are. So I also like to remind the audience after playing that piece that that also is 36 years of data that they listened to in just under 3 minutes. So again, to sort of think about the duration of change over time. So those are a couple samples of sonifications of music pieces that I've made with climate data that I'm sharing, and we use them in undergraduate classes at the University of Washington. They're shared on social media. But I did something new this Sunday. For the first time, I taught young people how to make pieces of their own in this sort of experimental workshop. And since you're an audience of educators, I would love to share this with you and get feedback or ideas too. So it was a workshop actually with Christina Lee, has a music studio, and she was the performer you just heard. So it was with her students. We ran 2.5-hour workshops. One was for ages 9 to 11, 12 to 18. There were 6 students in each workshop, so it was quite small, which was great. And it was at a music school, so many of them already had, they had backgrounds in piano, and they were able to read music. Some of them had done a little bit of composing themselves. So, but it was really racked my brain to sort of think, wow, in 2.5 hours, there's so much to bring together. We're like smashing music and composition and numbers and data and climate science and expression all together. So this was my approach to this. The first sort of section in each workshop was just to think in kind of an abstract way about numbers and notes and how to go from numbers to notes on the piano. We had a short discussion about what is data, again in an abstract sense. And then I gave for each workshop, I sort of gave them a set of numbers that wasn't data, it was just numbers. In fact, the first group, the younger group, I gave them numbers that mapped to Twinkle Twinkle Little Star, but I didn't tell them what that was, and asked each of them to go to the piano and turn that into a melody using the keys as numbers. And we could see there through that exercise that you can take the same set of numbers and make many different melodies out of it, and you have a lot of musical choices that you get to make as well. And that worked really well for them to kind of open up to thinking about translating numbers to notes. Then the next section was looking at climate data. So I had the biggest preparation for this was like gathering data in a good format for them. So I used the Global Historical Climatology Network, and I chose temperature from cities around the world. And I asked them in advance to tell me if they would like a particular city data to work with. And I'm going to jump to the next slide. So this is an example. I printed these out. So we had, I don't know, about 20 different cities they could choose from. And so I had 1-year averages, 2-year, 5, and 10-year averages. And we talked a lot about what you can see, what's kind of how you have to acknowledge data quality, and what you learn from averaging over different time periods. Colombo in particular had a lot of gaps in the data, but everybody realized, like, if you look at 1-year data, it's going to be too long, it's going to be hard to tell what's changing over time. So that was a really nice discussion to think about why we have to look at averages if we want to see longer term change. And then the next section was, we took a break, and then we have kind of this reflection on climate change itself and what that means, how they feel about it, whether they've learned anything about it, what their experience is. And that was pretty diverse. Some students had not really learned anything about it, and others felt very strongly and had some lessons from classes about it. When we talked about, how music can help to promote awareness and express science with some emotion, because several of the students did express and shared with each other their feelings of fear and frustration about climate change and sadness. Actually, several of them wrote also about feeling very sad. So I forgot to say, we did a pre-reflective survey before they started the workshop to think about, so they could identify their feelings and their exposure to climate science. And then the last bit was them working independently to compose from the climate data. And I scaffolded this, so showed them how they could take their notes, and they had to choose a reference point on the keyboard and map each of their data points to the scale that they chose. And then they had some time to work on that on their own. And all of the students in both groups left with a completely sonified data set that you can build from and perform at an upcoming concert if they want to. And I'll show you now what some of these samples look like. So these are 3 different outcomes. A student chose Galway, Ireland, and she identified right away, like, well, there's not very much change over time in Galway. It has a very nice long record, but it doesn't show a lot of warming. And she decided to show these bottom notes are 10-year averages of temperature, and these are 5-year averages. So she wanted to have a couple lines of music going on at once. One student wanted data from Shkodra, Albania. This was her composition. Another student, Sydney, Australia, and you can really see here, depending on what scale they choose, it's just like choosing your y-axis. You can have the data span a huge range or not. So they did make different choices there about, how far apart the differences in temperature would be on the keyboard. So Sydney, Australia just screeches at the end. And these are pieces that they can, these are very, very short right now. And so this is something they can build on if they want to take this and use this as a melody in a longer piece or draw it out in other ways. They can go forward and do that. So this is what it looked like. This was one of our first groups, and I'll share with you some of their survey answers when I asked them how they feel when they read, think, talk, or hear about climate change. This was before the workshop started. One student said it's very sciencey. When I read it, I immediately assume it means the overall climate, weather, temperature in a certain place. A student said it was sad. The world is changing in a bad way. An older student, the oldest in the group, said it's a stale topic. It doesn't carry the weight that it should. It's like listening to someone tell you about some sort of bad event, except it's too far in the future to really feel worried about it. Another student said, I think it's about the annihilation of the human race as a result of an uninhabitable Earth. One student said, I don't know exactly what climate change is. And then another said, I feel a sense of fear. So it was helpful to have that kind of background reflection time for them, both to help with the discussion, but also for me to see what they felt and knew about it coming into the workshop. And then in the post-workshop survey, I asked them, how do you feel about climate change after making music from data? And I'll share just a couple of the responses here. One student said, I see it as a more tangible idea that needs to be spread. And that student chose to sonify data from Colombo in Sri Lanka. And she has grandparents living there now. Another student said, I feel climate change can be dangerous, but composing about climate change can help you learn more about it. That student was working with data from Jakarta. And then the student who sonified the data from Sydney said, I find it interesting how it gives a new perspective. And then I also asked, how does the piece that you composed sound? And they said, well, my piece jumps around because I assign each note to 1/10 of a degree. However, it increases toward the end. And I was really pleased to see them write that, because that's exactly what's going, that's exactly sort of understanding the relationship between weather and climate, that it does jump around a lot. And the signal, you may not hear it until you get to the end of it. Another student said something similar. It kind of goes up and down, but in the end, the pitch really increases. Another student said, it sounds edgy, but not too dramatic, as the temps were really close together. And the last student shows, it shows that the temperature in Galway is not as affected as other cities, and it goes up and down, but stays in the same area. So well, actually, I'll keep it on this for a second. So the discussion, when the students each got their own city data and we asked them to look and see what they found, it was a really rich exploration of how, even though they know climate change means warming, when they look at individual cities, some don't show much signal and others show quite a lot. And I was really pleased to see how that came out for them and became clear to them, both in their discussion and then as they went to the piano and worked on their piece by themselves. So here are some of the lessons from that. They discovered the evidence of warming, how it varies across cities, both spatially and temporally. They made choices about what timescales to use, so they had to choose if they wanted to use 10-year averages or 5 or 2. None of them wanted to use the 1-year averages because that was too long. That would take too much, there were too many data points, basically. And they also identified experientially that climate change is best felt and understood by looking at longer time averages. Most of the students, 9 out of 11, chose cities from which they were born or had a personal connection, not surprising. And students have the option now to continue developing their piece at home or with their teachers, and they can perform it at an upcoming spring music show. So stay tuned for that. So that's the outcome of this work of now putting this skill into the hands of young people. And I, at this point, would love to have more discussion about this with you all. That's the last of my slides.
Okay, thank you very much, Judy. Are there any questions?
Yes, Judy. Jim Callahan, climatechangeeducation.org. One is, in what you've produced, what is online and so on, what is your attitude, what do you do on the matter of other educators using it within, say, videos of sound, right? Is it licensed? Of course, attribution, of course, linking to you, but what's the ability for us to, say, put this part of a soundtrack on another science education video around climate change?
Yeah, you're open to do that. In fact, the Keeling curve one, I have that as a YouTube video, and I produced that together with Dargan Frierson. And so this is already available. And actually, we published it, I guess, with UW Atmos Outreach. So really, really happy for you to use that. And also the video that you saw with Christina performing, that's also available on YouTube, so you're welcome to share that. And then the pieces on my website, I think they're all Creative Commons. So my goal is for them to be used and heard and listened to and at the service of educators.
Great. And a follow-up on that, would it be possible to write you on a certain thing to actually get an Adobe Audition file so that we can, get the best quality on that?
Yes.
We have an Adobe Audition, no problem. So, okay.
Mm-hmm. Yeah.
And does the volume stay the same on the Keeling curve?
So this is a great question. Yes, I mapped it to constant volume. However, there's interesting, that's called psychoacoustic effects. So as the pitch rises, we perceive that it's getting louder, even though it's equal amplitude the whole time. So basically, from a human perspective, it's getting louder, but from a physics perspective, it's not getting louder.
I was one thing. This is Tamara. I was kind of concerned as it started going that it would get to the point of hurting, and I know some people have more sensitive ears than I do. Was that an issue at all, or no? Or
I mean, I think you have to check your speakers so you know that it's getting higher and will sound louder at the end. One of the things, I mean, Dargan Frierson uses this in his classes all the time, and he says, well, it's really good that it's only a minute and a half long, because it does get loud at the end, but then it's over. So yeah, I mean, I think you just have to check your speakers and make sure you're not going to blast them with it. Yeah. But a little bit of it getting uncomfortable, I think, is appropriate, right? It depends on, you have to know your audience, but
right.
I agree. It's reaching high.
It's just that most people really don't know the sound sensitivity of their student. It's probably not something that comes up often.
Yeah, right.
Yeah.
Yeah.
Okay. Any other questions?
Yeah, this is Ingrid Zabel. First, I just want to say, wow, this is really amazing and interesting work. So thank you for presenting it. And I liked seeing the reactions of your students, the ones who had been involved in creating the music, and what they thought they had learned from the experience. And I was wondering, do you have also reactions from people who didn't create it but just listened to it, which is sort of like us sitting here listening to it, but other students or other people who are hearing it for the first time?
Yeah, so that's another area of research I didn't share much here. So I have a lot of anecdotes, and I should say one of the reasons I decided to design an interdisciplinary PhD to do this was based on immediate reactions and feedback from the first piece that we sort of published was that Keeling curve piece, and a lot of, this is all like non-scientific feedback, but educators at UW started using it in their classes. People told me that they remembered it several months after hearing it. Reporters wanted to put it on the radio, so it went on NPR. So I just saw there's a real craving for different ways of relating to climate data. But more formally, I have been, and I'm in the process of analyzing results from surveys where we presented a piece in classes that teach the science of climate change, large undergraduate classes, and looking at the results of those. And I have to say, I was asking questions for them about whether or not they, some questions like that might come up on a test to see, to see if it had any difference on their sort of understanding explicitly of the science. And then I've just finished a survey of looking at the memorability of listening to this a year after the exposure in the class. And the results are not finished yet. I just closed that survey like last Friday. I will have to say it looks, just from quick surveys, that it's really hard to sort of see this difference between, so I did a test in a control group. The test showing sound and the control group looking at visuals. And I don't think there's a huge signal between the two groups. So we'll see, but I'm not done with that analysis. So I'd be happy to share that when it's done.
Thank you.
Mm-hmm. I'm also curious if many of you are, so this was this workshop I did with the young people last weekend. If you have feedback or ideas, because this is just the beginning of it, and I would love to do it again, but I'm also, I don't study pedagogy. So this was sort of me thinking, well, what's a great way to scaffold this? So I'm also curious if you have ideas or suggestions or thoughts on, incorporating this into other music education settings.
This is
Judy?
Tamara. Let me just ask a quick question here. I've done a lot of work in terms of developing curriculum to help students develop a deeper understanding of change over time and space. Were you able to, or did you try to focus on whether students develop a better understanding of change over time and space? Or because you mentioned at the beginning the time scales that you were addressing, how different they were.
Yeah.
And it's really hard for students to go from seasonal cycles to millions of years, and
Right.
Things change different over those periods of time. But our goal was to try to get students to develop a deep enough understanding that they could transfer that understanding to other contexts. I was wondering if you explored that at all.
No, I haven't actually. So the timescales we were looking at here, I had each of them with their city data, and they had this as a printout, and they were looking at yearly 2-year, 5 and 10 year averages. I also hadn't worked with these students before this 1 2-hour workshop, and this was in the context of their music education. So it was interesting to see a lot of them, their heads turning like, oh, I'm doing math right now, and I'm doing math, but this is my music studio, and so
it's nice to see math integrated into music, and that they could interact in the students' heads.
Yeah, it was really fun to do that. I love transgressing those boundaries of disciplines, doing this with them. But yeah, okay, I would love to. Yeah, well,
go ahead.
I guess I just know anecdotally not anecdotally, but from these surveys, that they are both in their pieces and also in the way they talked about it. They really got to see that if they wanted, some of them, like, they wanted to see a big signal in their city. And the student who worked with the data from Galway was like, it just jumps around, right? It doesn't actually go up. But everybody realized, like, in the cities that do have a strong warming signal, you best see that if you look at the 10-year averages.
Okay, there's somebody else who had a question?
Yeah, Judy, thank you very much. This is exciting to see this exploration. I'm the climate education coordinator at NOAA, so I love seeing our data in a new way.
Good.
But one of the things about the work with the students that was interesting was the fear and the scariness of this topic.
Yeah.
And one of the things, like with the Mauna Loa data or the global CO2 data, as it goes up, right? The real grand question is, will humanity bend that curve and bring it back down?
Right.
And all our future climate models are looking at, different scenarios that will get us there. So I put in the chat the 1.5 degree reports and some of the graphics about that, about projected future. The future is kind of that choice part. Does it continue to rise in pitch, or does that pitch flatten and then begin to come down? I'm sorry, I'm not a musician, so use my language if it makes no sense.
No, it makes perfect sense.
Where are we going beyond it leads to a moment where the unwritten part is more choice as opposed to observed. Does that say anything?
Absolutely. Yeah, and so, I mean, I have done one unpublished piece where I looked at model data in different scenarios, and I want to explore that more. I think that's helpful. I've tended to go towards observational data because you can point to exactly where it comes from and to the ecosystem, or to the, there's more physicality to it that I like, that I think can help people really relate. But I absolutely agree. And one of the things I've been tossing around with a jazz artist is the prospect of using a piece that's both scripted from the historical climate data, and then part of it's improvised based on what the performers think about different future scenarios. So those are ways in which you could really adapt this to think about the uncertainty, I don't want to say unpredictability, but the openness of the future and how it's dependent on human choice. Right. I also think, though, it's really it's really helpful for me at least, to start assessing students' emotions. And I've done this in my undergraduate surveys too. That's part of this research. And I mean, it's like 70–80% of them use words like fear, anxiety, sadness, hopelessness. Some say guilt. And it's really, really common. It's very widespread. And I think if we don't allow any discussion about that, it's hard for people to understand. I mean, that's so connected to our feelings of care for it, right? That we do feel sad and we recognize that there's devastation and loss, and that needs to be part of the discussion. So when I had this discussion with the students, we didn't go too extensively into emotions, but I told them I started making music because I wanted to find new ways to communicate this information in a way that it expressed how I feel about it, and also because I'm very disappointed in leaders. Scientists have been talking to the international community for decades, and they haven't done anything. I mean, I really didn't try and sugarcoat how I feel about it, and they got it, I think.
So I think you're tapping into. I'm sorry for the quick follow-up, but I think one of the things I think we've not done well in the community is when we say we haven't done anything, we misalign a lot of times how much we've actually done, and we perceive that we have yet to do, as opposed to acknowledge that we've done so much but have yet so much more to do.
Yeah.
A big difference between those two. And if you want to explore kind of that space, because I was in the U.S. delegation for the UN process that got to COP21, the Paris Agreement, right? And you felt hope there, and now you're feeling less hope, but still hopeful in certain places. So I think that whole space is incredibly important. But if we leave everyone feeling completely fearful and lack the opposite of hope, right, despair, then I think we haven't completed the piece.
Right. Yeah, I agree completely. But I also don't think that we're responsible for other people's affective response to this information, to their emotions about this, and that there's certainly a lot of choices in the way that you present the data that can create a certain emotional, tone and texture. But it was really interesting to me to do the pre-surveys before we had any discussion, and just to see where students were at. One student who said, she's 9, and she said, well, I don't know anything about climate change. And I didn't include this in the slides, but she said, but I think it's something bad. So yeah, they understand sort of maybe through osmosis how the culture thinks about it, even if they haven't consciously identified that they understand it or have learned anything about it in school.
Yeah, Judy, a few things. The music and sound have very much been part of our work over the last 20 years, but a lot of it being also a lack of musicians who are focusing on it. I mean, for one would be, if you go and you look for music meant to go along with education on climate change, most of what's out there is essentially clickbait. Somebody who knows that climate change and global warming is going to get attention, but the music has nothing to do with it. It's just people have done that.
Yeah.
But yet it is very important. One is, if you want to see a video, if you want to look at a video or movie and know what feeling the developer is wanting to convey, listen to the music. That's the first thing indicator. What emotions are they looking for their material to get out? I think one is an example where data is such more powerful when there is sound going along with it. There's a video that's fairly popular on YouTube of the nuclear tests that have happened since Hiroshima, all the way through, where there's sound that goes along with each of the explosions, and you see that they're going on. It's it would not be as emotionally powerful without the sound that goes with it. That's a good example with it. And I think also you are taking on a territory which is much needed and is very rich. You're hitting at a very important example of where it's rich. An example where we refer to it but don't have music to go along with this is this. In both understanding what goes on with climate change, how it works, and how we are taking it on, how we are successfully taking it on, and what we need to do, there are science principles like the following. Humans are used to dealing with a small band of the infrared, of the ultramagnetic spectrum, light. And yet we're often told to take the rest of the electromagnetic spectrum where global warming takes place and reduce it down to one note, because we're so afraid of trying to raise people's scientific understanding. So we just say it's infrared. Well, if light were sound, what we can see is 1 octave. And infrared, where most of global warming takes place, is 10 octaves big. We want to explore that. And that's an example where music can get, we need to expand our range to the rest of the keyboard, right? We're used to looking at this 1 octave, but there's all this music, there's all this going on, which can both be scary and exciting and exploratory, and you can make a difference to save the planet, right? There's always the scary and the hopeful going side by side if you take action. That's an example that we have often referred to, is to get people to understand there's all this light that we can't see, and it's 10 octaves big. And you've never heard that music. Do you want to start hearing it? It's exciting. So I want to just applaud if you're putting musician skills into this, it's much needed. Thank you.
That's such a great idea. Thank you so much for sharing that. Yeah, I love thinking about that.
Hey, Judy, this is Patrick, and I know we're just about out of time, but I'm sure we'll have a follow-up conversation. Great to hear about your work since AGU, and I look forward to talking more. But something I've been working on a lot in the realm of art science integrated lessons is establishing a baseline of knowledge through the art methodology that you're teaching with. So if you're teaching embodied climate communication, establishing an understanding of where we're at with climate through embodied methods. And I think it'd be really interesting to explore how to establish that baseline of knowledge in your workshops using music, not just, okay, let's talk about science and then do music, but using music to get everybody on the same page before going into some of the sonification.
Well, I guess I think of the sonification as part of, like, we did it throughout the workshop. Yes, I guess I would love to talk with you more about this. I know you said you're working on this already, so I'm not exactly, I guess I'm agreed and would love to talk more about that. I mean, one of the things I remember the students saying is like, wow, you really hear it go up. Another student, this was in the surveys too, is like, I felt it. And that's, that's something I haven't seen students say before. So that was really, really interesting to see that outcome.
Oh, absolutely. I really appreciate the work you're jumping into. I'm excited about it. I think it's interesting, though, to explore that concept of let's take a look at the world through sound and then work to create the sonification too. It's fun stuff. Look forward to talking.
Great. Thank you. Yeah.
All right, thank you so much. Well, we're a minute past the hour here, so I want to respect everyone's time. Tamara had to leave for another meeting, so I'm just going to help finish up the call here. This is Katie.